Hello everyone. Today we are going to start a session on azeotropic mixture. This is the chapter number 2 of plus 2 chemistry. Let us take up the session. First point comes into our mind is what is azeotrope, what are its type, and what are TX diagrams. We are going to take up all one by one. So let us start the topic first with the question. Can you tell that can we separate ethanol from a mixture of ethanol and water beyond 95.57%? Is it possible? This is the question. Whether we can increase the concentration beyond 95.57% ethanol from a mixture of ethanol and water. This is the question. Now you may have thought the answer. We will get this answer after the end of the presentation. Azeotropes. Azeotropes are constant boiling mixtures. Generally one word we say. These are miscible. They boil at constant temperature and they behave as a pure liquid. What is the meaning involved? That we are having ethanol water system, let us say. One component is having lesser boiling point and another component is having higher boiling point. Ethanol is having lower boiling point, water having higher boiling point. When you heat this mixture, ethanol vapor will form and we can separate. But what happens is at a certain concentration, that is the particular concentration and particular temperature, both of the component ethanol as well as water is coming in the vapor phase. This is the problem. So thereby boiling point becomes constant. No separation is there at that point. So that is called as azeotropic point. And the mixture is known as azeotropic, azeotropes or azeotropic mixture. Other examples are butanol and water, HCl water, nitric acid water. These are other examples. So now you are clear about azeotropes. Azeotropes are miscible liquid which boils at constant temperature and behave like a pure liquid. And the distillate has the same composition as that of liquid phase. So now the examples, two examples are there. Minimum boiling azeotrope and maximum boiling azeotrope. These are the types. Examples already I have discussed. Ethanol and water, butanol and water. Hydrogen chloride and water, nitric acid and water, these are the examples. If you talk of minimum boiling azeotrope, you can see from the diagram, it shows positive deviation from the ground state. Means positive deviation means pressure is higher. Pressure is higher means boiling point is lower. So you can see there is a dip. If you see the boiling point, one point is 100 degrees Celsius, that is the boiling point of water. Another boiling point is 78.5 degrees Celsius, which is boiling point of ethanol. And the boiling point of a mixture at 95.6% ethanol is 78.2, which is lower than both of the components. This is the characteristic of minimum boiling azeotrope. Right? So the curves, if you can see this line, vapor phase line, and this is liquid phase line, and both temperature boiling point are higher as compared to the mixture 78.2 degrees Celsius. Means that comes to 351.15 Kelvin and 95.57%. So thereby we say that normal distillation, if you are doing ethanol and water up to 95.6%, we can saturate. After that, concentration is not possible to increase beyond it if you use simple distillation. Now come to the next, maximum boiling azeotrope. Maximum boiling azeotrope means negative deviation. Negative deviation means pressure is less. Pressure is less means boiling point is higher. You can see from the curve, this curve, boiling point of water is 100, boiling point of nitric acid is 86, and the boiling point of the mixture at concentration of 68% is 120.5. Means the boiling point of mixture is more than the each of the component, water and nitric acid. So this is the maximum boiling azeotrope. Boiling point is higher. Negative deviation, nitric acid and water system. So these were the two examples with the curves. These curves are known as Tx, temperature in the y-axis, mole fraction in the x-axis. Now the question which we have started, can we separate ethanol from a mixture of ethanol and water to more than 95.5%? This is the question again comes. The answer to that, it is no when you use simple distillation, but we can separate if you use azeotropic distillation. Azeotropic distillation, if you do that, we can separate, but it is beyond the scope of the syllabus. Okay. So today what we have understood about the types: azeotropes, minimum boiling azeotrope, maximum boiling azeotropes, and the Tx diagrams. So thank you for watching this video. If you have understood the idea of azeotropes, do share. Please feel free to contact on the given email ID. You can download the app. You will be having access to the free tests in the app. Along with that, if you want to buy any course, you can do that. Thank you everyone. Thank you.